In the past few years, a lot of research has been done to make machine learning algorithms much more efficient. Rather than just running complex neural networks and other algorithms on giant computers, we can now run them on smaller, more power efficient devices. An embedded system is any computer system that is contained or embedded inside of another larger mechanical or electrical system. This is opposed to things like desktops, laptops, phones, and servers. Single-board computers like this Raspberry Pi can be considered embedded systems if they're implanted into some other device, like a robot. Similarly, microcontrollers, like the one on this Arduino board, are generally considered embedded systems as well, as they're often used to control physical or electrical devices with little or no human interaction. Single-board computers usually have a more powerful microprocessor with separate memory, are capable of running a full operating system like Linux, and can provide a full user interface, whether that's a command line or a graphical UI. Processor speeds are usually on the order of hundreds of megahertz or in the gigahertz. RAM is in the hundreds of megabytes or gigabytes. A microcontroller is usually much cheaper but much less powerful than a single-board computer. You often program it with a simple bare metal superloop, or if needed, you can turn to a lightweight operating system like a real-time operating system. Most microcontrollers forego a user interface, or if there is one, it consists of a few buttons and a simple LCD screen. They also generally require much less power to run than a single-board computer. Most modern machine learning frameworks were developed for desktops and servers running high-level languages like Python, so it's often easier to run them on a single-board computer than it is on a microcontroller. That's assuming the single-board computer has enough power to accomplish the task at hand in a timely fashion. You can get things like scikit-learn, TensorFlow, PyTorch, and Caffe to run on a Raspberry Pi without much of a problem. However, very little has been done to get these frameworks running on microcontrollers. That is, until recently. A few years ago, the Google TensorFlow team released a stripped-down version of TensorFlow Lite specifically designed for microcontrollers. This allows us to run simple neural networks on microcontrollers at a high level without needing to manually program the matrix operations. Additionally, lots of optimizations have been done in code and by microcontroller manufacturers to make these frameworks and other machine learning algorithms run much faster on these tiny controllers. Executing some matrix operations on a microcontroller isn't really anything new. It's a combination of the software and hardware optimizations in the last few years that have allowed us to run more complicated machine learning algorithms on these microcontrollers, and that is where the magic begins in the embedded world. We can start to have voice-activated systems embedded in our homes, or maybe cameras that can identify specific objects or people. Wildlife researchers are continually finding new ways to track animals, and identifying specific calls can be a key to that ability. Additionally, industrial and space equipment can be expensive to produce and even costlier to repair or replace. We can use machine learning to detect anomalies in their operation before something actually breaks, potentially saving thousands or millions of dollars. These are just some of the scenarios where embedded machine learning is changing the way we use electronics. If you've written firmware for microcontrollers before, you're probably used to having everything be deterministic. For example, if a temperature sensor reads a liquid temperature over a certain threshold, then the microcontroller opens a valve. The determinism comes from the fact that there's no randomness in this process. When event A happens, perform action B. On critical systems where missing an action might end a mission or cost a person's life, determinism is everything. Imagine using a microcontroller to control an engine, and you can't quite control the timing of some of the spark plugs. This would likely end very poorly for that engine. This is why interrupts and real-time operating systems are so popular with embedded developers. The timing of events can be precisely measured and controlled. Now, imagine you're working on a new type of emergency stop button that triggers the automatic shutoff of some manufacturing equipment whenever someone shouts, "Stop." This might seem like a good idea in theory, but you can run into some issues. Machine learning, by its nature, is probabilistic. It involves developing mathematical models that broadly represent trends in the data used to train it. As a result, it can't really guarantee that when someone shouts "stop," it will recognize that word. Maybe it's 99% effective, which is really good for a speech recognition system. However, that 1% miss rate might mean someone gets hurt or worse, killed. Even a 99% effective rate is probably not good enough to get your emergency stop device approved by OSHA or your medical device approved by the FDA. It's important to understand that embedded machine learning is not a magical fix for everything. It can supplement other deterministic functions, or it can offer unique solutions to problems. I encourage you to keep these limitations in mind, but also be on the lookout for new ways that machine learning can potentially be used to solve problems.